our stream. Hello, hello. Hope everyone's having a good day. Just confirming that everything is loading up as it should. Takes a few seconds. Go. So far, so good. Stream has started. Hello, hello, hello. Yep, good, good. So we've got good sound. All right. Go over here, view channel. Check this volume. Hello, hello. All right. So today is August 13th, 2026. It is currently 2:32 in the afternoon. And so now it's time to go ahead and get back into the work of it. So what am I doing? I am copying Augustus De Morgan's The Elements of Arithmetic, currently on page number, let's see here, page number 33. Page number 33. Zoom in. Oh, come on. Come on. There you go. So currently page 33, and we are going through the rules for how to add numbers, add more, how to do addition or subtraction for numbers that are greater than 3 digits in length, greater than, I believe, 2 digits in length. But anyway, so the purpose of this stream is to simply do review of mathematics, and also to practice it's also important to practice the Gregg shorthand. So relatively recently, I've been more devoted to Gregg shorthand, and so therefore I'm taking this as an opportunity, both in my efforts to become more proficient in mathematics. So I'm going back through these old textbooks. For instance, this one is from 1830, and I'm using it as an opportunity both to go over the concepts, but also to go through the process of actually writing out the textbook using Gregg shorthand. So it's kind of a multi-purpose project. Okay, so. So without further ado, let's go ahead and get into it. If you want to take a look at any of the links, they're down below in the description. I'm just going to go ahead and start in, okay? So we're on rule number 3. Okay, and write down the units of these numbers. Write down the units of this number under the units of the rest. If you want to take a look at the book, it's available down in the description. You can look at... There's a copy to the PDF version on Google Books, and the Copywork is in Gregg Anniversary, and you can link to the shorthand manual, so on and so forth. All the good stuff. All the good stuff is down below in the description. So, let's go. Number 3. Write down the units of this number under the units of the rest. Write down the units of this number under the units of the rest. Under the units of the rest. And keep in memory the number of tens. And keep, oh, I'm accidentally copying and recollect in 3. That's what it was. Which you were told to recollect in 3. Oh, okay, that's what it was. I'm copying the wrong portion. There we go. Comma after 3, and divide this number of tens in tens and hundreds. And if you're curious what came before this particular copywork, it's at the end of last stream. And divide this number of tens and hundreds period. Thus, if 335 tens, thus, if 335 tens be the number obtained, and let's see if that's obtained. Yep, that's obtained. Comma, part this into 33 hundreds and 5 tens. Part this into 33 hundreds and 5 tens. Period. Then our next point is number 5. So a paragraph marker and then 5. Place the number of tens under the tens. Place the number of tens under the tens and remember the number of hundreds. Period. Number 6. Proceed in this way through every column. Proceed. Make sure that's proceed. Proceed does not require a D. And we'll scroll down. Proceed in this way through every column. Proceed in this way through every column, comma, and at the last column, at the last column, comma, instead of separating the number, you obtain into two parts comma, write it all down before the rest. Write it all down before the rest. Period. And then we have an example given here. We'll go ahead and do the example. Why not? Once again, it's good practice. So we have this layout here. We have, ready? We have 1005 plus 36 plus 1000 plus 19,727, 19,727. Oh, they go towards. Plus 3 plus 1,474. 1,474 plus 2008. Okay, 1,805 plus 36 plus 1,900 or plus 19,727. Plus 1,474 plus 3 plus 3 plus 1,474 plus 2008. And then we do this, the addition of the units line. So what do? We line this all up vertically so that we have all of our columns in the same, or we have all of the units, tens, hundreds, thousands in the same columns. Okay, so we'll start first with, we'll do it in the order given. So we'll do this here. Okay, so 5, 8. Yep. 1, 8, 0, 5, 3, 6. And then we have a 19,000. 727. 727. 3. Okay, try and keep it all vertically aligned. 1,474. 1,474. And finally 2008. 2008. And we add up these values in this manner. We start first with the units place. The addition of the units line, or 8, 4, 3, 7, 6, 5, gives 33. Gives 33. That is 3 tens and 3 units. So we could add another 3 up here above, right? An invisible 3. And then put 3 in the units place and add together the lines of 10, taking in at the beginning the 3 tens, which were created by the addition of the units line. Okay, so we have this element here. We take it in at the beginning, 7, 2, 3. So this is 12 plus 3 is 15. So we then add a 15 for the number of tens, that is 100. So then we do 1, 4, that's 5, plus 7 is 12, plus 1 is going to be, 13. Right? 1, 4, 7, 8. Did I miss one? We're in the hundreds, right? 15, hundreds, 1 and 5. Add the line of hundreds together. 1, that is 1, 4, 7, 8. Where's the, there's the 8 right there. So I got to be careful with that. So we got to make sure that we're lining up everything correctly. So undo, let's go ahead and fix this here. Line up the 8 there, line up the 1 there. There we go. So now we can see these in order. So we have the 1 here at the beginning, which is 5. 5 plus 7 is 12. And then plus 8 is going to be 20. So we add a 0, right? And we have a 2. So now we add 2 to the thousands. And that's going to be 4, 5, 4, 5. That's going to be 14. Yep. That's going to be 14. And then plus 1 is going to be 15. So that's going to be 15. Yep. Put in the hundreds place, which is 15. So we add that up here. 5 for the 15. And then we have 1 left over. So we have 1, which then gives us 2. Okay. And we're going to go do a parenthesis there. So that's going to be 25,000. So if we look at it, 25,053 is going to be the value. So now that was the total quantity, and I'm going to go ahead and copy it down as well, just for the practice of writing the shorthand. Because remember, this is in fact, this is mostly a shorthand practice, and the arithmetic is just the material that I'm using to practice writing the shorthand until I have gained further proficiency. So it's like beginner's beginner. So it's like teaching a toddler how to ride a bike and walk at the same time, I guess. So we have the addition of the units line or 843, 8, 4, 3. Oh, and this should be on the other side. Rats. Just saw it in the value. Yeah, there we go. All right, so we have 8, 4, 3, 7, 6, 5, comma, gives, and gives does require the S. It gives 33, comma, that is 3 tens and 3 units. That is 3 tens and 3 units. Put 3 in the units place. Put 3 in the units place. And add together the line of tens. And add together the line of tens. There we go. Comma. Taking in at the beginning the 3 tens. Taking in at the beginning the 3 tens, which were which were created, there we go, which were created by the addition of the units place, which were created by the addition of the units place. Of the units line, not place. Period. That is, find, so we go, that is, find 3 plus 0 plus 7 plus 2 plus 3 plus 0, comma, which gives 15 for the number, which gives 15 for the number of tens, semicolon, that is 105 tens. That is 105 tens, period. Add the line of hundreds together. Add the line of hundreds together. Comma, taking care to add the 100. Taking care to add the 100, which arose in the addition of the line of tens, which arose in the addition, in the addition of the line of tens, semicolon. That is, find 1 plus 0, find 1 plus 0 plus 4 plus 7 plus 8, comma, which gives exactly 20 hundreds, which gives exactly 20 hundreds, or 2 thousands, and no hundreds. Put a cipher in the hundreds place. Oh, I love that. I love cipher instead of 0. Put a cipher in the hundreds place. Put a cipher in the hundreds place. Semicolon. No, not semicolon, parentheses. There we go. Because if you do not, you will die. Because if you do not, and do not, I think, is the DN stroke. If you do not, comma, The next figure will be taken for hundreds. The next... Ooh, figure. Isn't that just fig? I think it's fig. The next figure will be taken for... let's see. Will be taken for hundreds instead of thousands. Will be taken for hundreds instead... Oh, not insteads. Instead of thousands. There we go. Close the parenthesis. And add the figures in the thousands line together. And add the... make the G a little bit more grandiose. And add the figures in the thousands line together. Nice. Comma, remembering the 2000s which arose from the hundreds place. Which arose, I need to check arose, because I can't quite remember. Oh. Okay, how about rows? More rows? I mean, it makes sense. Once again, the Gregg gods do not need to tell me their ways. I just need to serve them. So I will add a rows to the list. Okay. Which arose. There we go. Make it just a little bit more simple. There we go. Which arose from the hundreds line, from the hundreds line, semicolon. That is comma, find 2 plus 2 plus 1 plus 9 plus 1, comma, which gives 15, which gives 15 thousands comma, or 1/10,000, or 1/10,000, and 5,000, period. Write 5 under the line of thousands. Write 5 under the line of thousand. Line of thousands, that is plural, comma, remembering the 10,000, remembering the 10,000, which arose out of the thousands line, which arose out of the thousands line, semicolon. That is comma, find 1 plus 1 or 2 10,000s. Find 1 plus 1 or 2,000 or 2 10,000s or 2 10,000s, period. Write 2 under the 10,000s line. Write 2 under the 10,000s line, and the operation is completed. And the it's not right. This is oh wait, what is operation? OPR. Oh, let's see. Let's take a look. Oh yes, it does require the Asian ending. Where are my Haitians? Haitian. Okay, so we have operation, and the operation is completo. Is complete. Isn't it just KP or is it KPL? Just KP, that's right. And the operation is complete. Go ahead and move this up a little bit on the line of writing, and we move this down. So that was all of 33. So let's go ahead and read back through what we just wrote. So we go back up to 33. And here, of course, you can see this is the arrangement of the letters. And once again, I apologize if any of the letters or any of the numbers are backwards. That is entirely my fault because I'm doing mirrored script. So I can do Gregg pretty well backwards, having done it for almost a year now, but numbers still kind of throw me every once in a while. So if you see numbers backwards, I'm not dyslexic. I'm just too adventurous for my own good. Okay, so let's go ahead and read. So we start at 30. Actually, we start even earlier because we're looking at all the rules as well. So we go back to 33. So there's rule 3, rule 4, rule 3. There we go. There's a paragraph. Bum, bum, bum. Jumping back up. Rule 1. There it is. So we're looking for when the last two articles. And there it is. Rule 1. So where's rule 3? There we go. There's rule 33. Let's line it up and we get started. Grab our little marker and we proceed, gentlemen. Here we go. Paragraph 33. When the last two articles have been thoroughly studied, you will be able to find the sum of any numbers by the following process, which is the same as in paragraph 29. And here are our rules. Rule 1 for the process. Place the numbers under one another. Units under units, tens under tens, and so on. Next rule, or next paragraph, add together the units of all and part the hundreds, and parts the whole number thus. Obtain into units. Is that obtain? Zoom down here and part the whole number thus. And so on. Add the numbers. Yes, obtained. obtain, add the units of all together, and part the whole number thus. Thus obtained, that's what it is. So what I need to do is I need to go, this is obtain, and then we would do obtained, like so, for the past tense. Thus obtained into units and tens. Thus, if 85 be the number, part it into 8 tens and 5 units. If 136 be the number, part it into 13 tens and 6 units. And then according to be 6 units, that's according to paragraph 20. And then here's our next rule, rule number 3. Write down the units of this number under the units of the rest, and keep in memory the number of the tens. Next rule, rule number 4. Add, is that add? Yes. Add together all the numbers in the column in the columns of tens, remembering to take in or carry, as it is called, the tens which of what? Which of, or to carry, which you were told to recollect in, step number 3, and divide this number of tens. Divide? Really? Hold on. Divide this number. Yeah, there we go. Divide this number of tens and hundreds thus. If 335 tens be the number obtained, put this into 33 hundreds. I forgot the H, little aspirate, hundreds and 5 tens. And here's step number 5. Place the number of tens under the tens and remember the number of hundreds. Step number 6. Proceed. Let's proceed. Proceed in this way through Sorry, I just saw I was distracted. I apologize, but I'll go back and then I'll read it. So we have step number 6, proceed in this way through every column, and at the last column, instead of separating the number of obtained, to separate the number, hold on, you obtain, that's it, you obtain into, we need to move down here, you obtain into 2 parts, next column over, into 2 parts, write it all down before the rest. And then we have this example here where we have 1,005, 36, 19,727, 3, 14, 1,474, and 2,008. So we take these values here, right? We line them up. And once again, I apologize if there are any numbers that are backwards, it's because I'm writing mirrored, and sometimes I forget and I write the numbers in the correct orientation, but in this direction they're supposed to be backwards, okay? So anyway, we take our first value, line it up, all of our units are lined up, all of our tens are lined up, all of our hundreds are lined up, thousands, and then our 10,000s. So remember, this is a linked counter system, okay? So we'll then read through the example, because after all, this is more of a Gregg stream, so that's why we're really focusing more on the Gregg, even more so than the mathematics. The addition of the units line, or 843765, gives 33. That is 3 tens and 3 units. They put 3 in the units place and add together the line of tens, taking in, let's make that dot just a little bit more pronounced. There we go. Good. Taking in it at the beginning, the 3 tens which were created by the addition of the units line. That is, find 3 plus 0 plus 7 plus 2 plus 3 plus 0, which gives 15. Which gives 15. Was that supposed to be a period, by the way? I'm guessing so. Hold on, let me zoom out. Oh, come on. Which gives 15 for the number of tens. That's it. Which gives 15 for the number of tens. That is which hundreds? That is what? That is what? 1. I can't even read a 1. That is 105 tens. Add the line of hundreds together, taking care to add the 100, which, oh, and I really need to put a tail on the 1 because I'm thinking of it as a witch. There we go. So I'm going to make sure I keep that. I give it its little header and tail. The 100 which arose in the addition of the line of tens, that is, find 1 plus 0 plus 4 plus 7 plus 8, which gives exactly 20 hundreds, or 2,000s, and no hundreds. Put a cipher in the hundreds place. Oh, we're getting close to the end. This was a long paragraph. Because if you do not, the next figure will be taken for hundreds instead of thousands, and add the figures in the thousands line together, remembering the 2,000s which arose from the hundreds. Ooh, give a dot there. There we go. From the hundreds line. That is, find 2 plus 2 plus 1 plus 9 plus 1, which gives 15,000s, or 1. There we go. We have to put the little tail on that so it's not a witch. Or 1 10,000s, and 5,000s. Write 5 under the line of thousands, remembering the what thousand? Remembering the remembering the 10. Oh, 10. Oh boy. Oh man, I almost thought that was a P. Yep, well, it's 10. Remembering the 10,000, which arose out of the thousands line. That is, find 1 plus 1, or two, or two 10,000s. Write 2 under the 10,000s. Yeah, so like this, that needs to be much more pronounced if I'm going to do a 10. Should be like that, otherwise it looks like a the. There we go. Hoi, almost there, almost there. Under the 10,000s line, and the operation is complete, and so is my brain. Oh my goodness. Okay. All right. Thank you. And I just saw your comment. Boy, that was 7 minutes ago. Mija Wu, or Mija Wu. Well, thank you so much. Thank you for stopping in and for enjoying this process, or for showing some interest in shorthand. I appreciate it. Oh, oh, that is interesting. Wow. Well, I'll have to give that some thought. My schedule is a little bit locked in right now, but if I have some time, if I have a little bit of an opening up, then I will definitely be interested. Oh, okay, Mike. Gotcha. All right, gotcha. Gotcha. Okay, well, yes, so you can send it if you wish. You can send it via I think my email is down below. So yeah, definitely. That sounds very interesting. My schedule's going to be a little bit more compacted coming up here shortly because I've got classes, university classes starting soon. So I'm not sure how much leeway I'll have to engage with more free shorthand, but thank you very much for showing the interest and for the invite. I really appreciate it. Okay, so let's go ahead and move on to our next paragraph, 34. As an exercise in addition, you may satisfy yourself that I now say of the following squares correct. The numbers in each row, whether reckoned upright or from left to right or from corner to corner, when added together give the number 2,456. Are you kidding me, Augustus De Morgan? No, I'm not about that. I am not about that. Okay, you guys can if you want, if you really need all that practice for addition. Ah. Oh, well, thank you so much. Thank you. Yeah, if you need this level of practice, oh, I don't know what to say. I'm not going to do all that because that's not Gregg. That's not Gregg, and also I'm way past the arithmetic stage. I'm just doing a review. So we're going to skip that, and I'm going to go on to paragraph 35. Okay, so let's go ahead and drop another line here. There's our little paragraph marker, and we're going to give it a highlighter and continue on. Okay, so 35, if two numbers must be added together, if now here's, I forget, I think it was Sean Griffin who dropped in last time and said that even if a number's written out, it's usually better to just go ahead and write the the Arabic numeral. I agree, because it just looks, it's strange to see the number and then to have to switch from grammar to number. So I'm just going to give it the number 2, even though it's written out with the writing. So if 2, and hold on, now I'm blanking. Yeah, 2 goes. There we go, yeah. All right, so if two numbers, whoop, come on, straighten out here, boy. There we go. If two numbers must be added together, comma, it will not, ooh, now alter. Alter is interesting. Isn't that that is a turned, I think you turn the R around, don't you? Isn't that alter? Let's check it. Yep, beautiful, beautiful. Okay, so there's alter. Let's see. It will not alter the sum if you take away a part of 1. If you take away a part of 1, whoop, comma, provided you put on as much to the other. Provided. So provided is going to be, I know it's this, and I don't think you even have to do the D going up. Let's see, there's provide. Yep, and then so provided would simply be the disjointed T. Very nice. So it is plain, provided you put on as much to the other. Provided you put on as much to the other, period. It is plain. It is plain that the rain falls mainly in Spain. No, that's not right. It is plain. Is that? Yeah. It is plain that you will not alter the whole number. It is plain that you will not alter the whole number. There we go. Of a collection of pebbles in 2 baskets. Oh, let's go ahead and add. I need to add another page below this. So this is page 6. Here we go. Elements of Arithmetic. Good old Augustus De Morgan. Of De Morgan's law, by the way, of logic, in case anyone's thinking about that. He's the same guy. So it's really impressive. So, section 2, page number, we're on page number 6 of the document. There we go. Okay. And we're going to slide back up here. Whole number. It is plain that you will not alter the whole number of a collection of pebbles. Pebs. I love that. Mr. Peb. Whole number of a collection of pebbles in 2. So like here, for instance, I'd go ahead and do the alphabet character 2. Not alphabet, the Hindu character 2. In 2 baskets. By taking any number. Basket. I'm pretty sure it's just a simple. I don't see any reason why you'd want to change it. Oh, basket's not even in the dictionary. Interesting. They do put an E on the end. Basket. Why would they put an E on the end? Why is that the case? Because that's from the dictionary. Basket? 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 I don't understand why you'd have to have the E on the end. It seems like it would be implied. But who might argue? The Gregg gods have spoken. They must have a sacrifice. All right, so basket. I'll go ahead and add that to the list later. So, it is plain you will not alter the whole number of a collection of pebbles in 2 baskets by taking any number out of 1. By taking any number out of 1, comma, and putting them into the other. and putting them into the other would make a pretty good, I think that would work as a phrase, into the other. Yeah. Just as long as there's a slight break there so I can see it. Thus, 15 plus 7, thus 15 plus 7 15 plus 7 is the same as 12 plus 10 is the same as 12 plus 10, comma, since 12 is 3 less than 15. Since 12 is 3 less than, make sure that's a little smaller, less than 15. Comma, and 10 is 3 more than 7. And 10 is 3 more than 7. We having trouble with connectivity? Yeah, we are. Sorry. I apologize for that. Looks like it's coming back up online, but we had some little bit of disconnection there. Hopefully we bring it back on. Yep, looks like we're connected again. All right. So where were we? Thus, 15 plus 7 is the same as 12 plus 10, since 12 is 3 less than 15, and 10 is 3 more than 7. This was the principle upon which the whole of the process in 29 was conducted. And once again, he's talking about paragraph number 29. This was the principle. Ready? So we go, this was the, and was, that would be a little bit, yeah, that's a little too much. We're just going to do was the, although that would make a pretty good phrase. This was the principle, and principle, I believe, is just, I think it's just P-R-I-N, but we'll go ahead and check. And that is correct. Good, good. So there's principle. This was the principle. Good. Upon which the whole of the process, upon which, so upon which the whole, let's go move this over, the whole of the process in 29, and once again that's paragraph 29 earlier in the book, in 29 was conducted. Was conducted is going to be conducted, maybe. Let's go take a look. There's conduct, and that is correct. So conducted is just simply the T, disjointed T below it. So there's conducted, period. 29 was conducted. All right. And that's the end of that paragraph. So now we're going to read back over it. We go back here to our previous paragraph. Did I forget to mark it? Or if to, yep, so I need to go ahead and give this a number, which is 35, like so. There we go. That's paragraph 35. I can actually squeeze it in there. Paragraph marker, and then 35. Dot. Go ahead and grab our highlighter, and we begin. 35. If two numbers must be added together, it will not, is that utter? Alter. It will not alter the sum if you take away a part of one, provided you put on as much to the other. It is plain, so now it should be it is plain. It is plain that you will not alter the whole number of a collection. I think that's collection. Number of a collection. Yes, collection of pebbles in two baskets, but by taking any number out of one and putting them into another. Thus, so let's go make this a little bit more pronounced. There we go. Thus, 15 plus 7 is the same as 12 plus 10, since 12 is 3 less than 15, and 10 is 3 more than 7. This was the principle upon which, and that should be moved up a little bit in the line of writing. There we go. Upon which the whole of the process in paragraph 29 was conducted. All right, so there's that. And now we continue. Okay, next paragraph, paragraph number 36. We scroll down the page, move it up, and here is 36. Let A and B stand for two numbers, as in paragraph 24. Once again, I really appreciate what De Morgan is doing here in laying out a book as simple as arithmetic. He's treating it with as much seriousness as you need for algebra or geometry. I mean, I've seen this level of severity and exactness in Euclid, in books of algebra, in calculus. So it's really neat to see him talking about arithmetic with the same level of exacting quality. Okay, part of it also helps that it was published in 1836 or 1830. All right, so here we go. Let A and B stand for two numbers. Let A, now if we're going to do that, we just do two lines underneath, so we are sure that we're dealing with the Latin alphabet. Let A and B, there we go, stand for two numbers. Stand for two numbers, a comma, as in 24, as in 24, period. It is impossible to tell what their sum will be. It is impossible to tell what their sum will be until the numbers themselves are known. Until the numbers themselves are known. Period. In the mean, while A and B stands for this sum, in the mean, so by that he means meanwhile, in the mean, while A plus B stands for this sum, stands for this, you could do it that way, for this sum. There we go. Period. To say, comma, in algebraic, algebraical, I don't know if that's in the dictionary. To say, comma, in, and let me check, I'm going to check my dictionary to see if I have algebraical. I'll bet you I have algebra, but I'm not sure beyond that. I have algebraic, and then algebraical is actually just as easy. All you do is you disjoint. You just disjoint the K. So we go like so. Okay, so this is that's algebra, and then if you simply pull the K away, then it's algebraical. Okay, so I'm going to go ahead and add that to the dictionary. Let's see here. Behavior, higher. Oh, I thought I had the other one here. Not yet, I guess. Okay. So let's go ahead and add it to the list here. This is algebraical. Algebraical. Okay. Very nice. So we have algebraical. Be adding that one. Let's continue. To say in algebraical language, and language is also a nice easy one, comma, that the sum of A and B is not altered, by adding C to A, by adding C to A, comma, provided we take away from, so let's go provided we take away C from B, there we go, comma, we have the following equation. I like this one. We have the following equation. Oh, what is equation? Oh yeah, it uses a W. We go equation. Let me check and see if that's correct. Oh, thank you so much. Thank you so much, Mike. I appreciate it. So there is equation. Yep, that's it. Good. All right, so now we have the following equation. Now for equations, that goes directly below on a separate line. I don't try and put it in the line of writing. So here we go. This is A plus C plus A. Ooh, yeah, this one's so clever. I like this one. I had to use a principle like this in it was a calculus problem where the only way you could solve it was by adding one and taking away one in the exact same time. It was it was really fun. You felt like you're doing a little bit of magic. So, and then B minus C. So that, yeah, this is a very, very important concept. All right. And all of that, A plus C plus B minus C is equal. So let me move this whole affair over one level here. That should give me enough room to then carry on with the rest. A plus, nope, is that right? Yes, A plus B. Okay, and I just realized I was kind of dumb. I don't need to put the markers underneath. There we go, because that's already implied that we're dealing with Latin letters. Okay, there we go. All right, and now, which may be written without brackets thus. All right, so now we switch back over and we say which may be, and maybe is a fun one as well, mab, which may be written without brackets. Ooh, brackets, that's a fun one. Bracket is B-R-A-K-T, right? Let's see, unless that needs an E as well. Yeah, oh, and bracket is not in the dictionary. I will go ahead and add it. Let's add it to the dictionary. Bracket. All I can think of, there's a scene in one of the Marx Brothers where Groucho is writing a letter. He's writing a letter, and his secretary is taking it down, and he's throwing in all sorts of just funny grammatical and punctuation. And one of the lines in there is brackets. So that's all I can think of. All right, which may be written without brackets. Thus, oh, and it should be plural. All right, comma, thus. Oh, comma. There we go. And now we can rewrite the whole thing. So we have A plus B plus, oh, I missed one. A plus C plus B plus C is equal to A plus B. All right, nice. Okay, so we have that. For the meaning of these two equations will appear to be the same on consideration. And he's right, because you can, oh, and nope, I take that away. That should be a minus. That should be a minus. Oh, okay, okay. Thank you, Mike. Yep. Got it. Hold on. I don't know if you're still here, Mike, or not, but is that Mike of the Mike Platt? I don't know if you're still here or not, but if you are, then also if you're of the same group, then thank you so much for sending over that information about the websites and the dictionary searches. I really appreciate those. All right, for the meaning of these two equations will appear to be the same on consideration. Of these two equations. Yep, so let's go ahead and add it here. For the meaning of these, for the meaning of these two equations will appear to be the same, will appear APR. Oh, okay. Well, you are welcome no matter what your last name is. All right. So we have for the meaning of these two equations will be the same. Will be the same, comma, on consideration. On consideration, and this is the cons, so we can go as it curves, and then no, it curves down. I think it comes down like this and then around for consideration. Let me check that out. Yes, that's right. Good. So on consideration. For the meaning of these two equations will appear to be the same, comma, on consideration. Appear to be the same on consideration. And that is really, see, once again, look at the beauty of what Augustus De Morgan is doing here. He's presenting concepts to, essentially these are grade school, right? This was taught in grade school, this arithmetic, and he's introducing concepts here that surely are not going to be very useful to the students right now, but by introducing them early, in a way it's kind of getting that circuitry in the brain starting to think about the concepts, so that when the actual time comes to do the work, you're all ready to go. Oh, okay. Hold on, sorry, your last part of your name. Gotcha. I'm reading the comments down here on this side, and the little heart symbol is hiding the last part of your name. But thank you again. Thank you so much. Thanks for joining. I appreciate it. So we have consideration. Now I need to go back and I need to reread through the paragraph. So let's go ahead, and before I go on, I drop a paragraph marker because I am notorious for forgetting those things. And we drop this here, do a little highlighter so we're ready to go. And let me jump back up to the previous paragraph, which is, once again, there it is, number 35. Number 35. Okay, grab a little highlighter. 35. If two numbers, no, wait, I already did that, right? I need 36. I'm looking for 36. There it is. And of course, like I said, I forgot the paragraph marker. I tell you. There we go. Boom. 36. Let A and B stand for two numbers, as in paragraph 24. It is impossible. I need to check impossible once, because I know that's important, but... Oh wait, impossible requires the B. Doesn't it? Nope, no, it just requires the S. I knew it was very, very close to important, but I had forgotten that. So we do impossible. It is impossible. There we go. let's go back. Here we go. It is impossible to tell what their sum. Let's put that. That is a little bit too shallow of a curve. Let's put a little bit more of a curve there. There we go. It is impossible to tell what their sum will be until the numbers themselves are known. In the meanwhile, a plus b stands for this sum, showing the general principles. To say in algebraical language that, is that correct? Hold on. Ah, zoom in, thank you. There we go. To say in algebraical language, yes, there we go. Good. Zoom down, come on. There we go. To say in algebraical language that the sum of A and B is not altered, by adding C to A, provided you is that we? Oh, undo. We take, yeah. Hold on, I think that's, yeah, there we go. Provided we take away C from B, we have the following equation, and this one is A plus C plus B minus C is equal to A plus B, and which may be written without, and that C or that TH needs to be a little bit more pronounced. Without, there we go. Without brackets. Thus, A plus C plus D minus C is equal to A plus D, or not D. It looks to me like a D, but it is a B. A plus B. For the meaning of these two equations, we need to do a little line underneath to show equations. For the meaning of these equations, these two equations will be the same on consideration. And now here's our next paragraph. But first, a little sip of water. Okay, so there we go, and we just continue on, plugging away. So now we go to 37, and we proceed down the line. There. If A be taken twice, if A be taken twice. Oh, twice is interesting. Isn't it? Oh yeah, this is tice. It's twice, right? Yep, that's it. Sorry, I heard some scratching. I just saw there's a little bird outside the window. I was wondering, like, is that my microphone? No, it was just a bird outside the window. Okay, so twice. There's twice. There we go. All right. So if A be taken twice, 3 times 3 times, comma, etc. I think, yeah, the and C, I think, stands for etc. Or what does and C mean? That's very interesting. I've seen it. It's an older symbol. You don't see, you never see it anymore. But let's go ahead and see what that symbol stands for. What does the ampersand? What does ampersand? Where's that on my keyboard? There it is. What does ampersand C mean? And the rest. Okay. Oh, okay, yes. And C, it's an old-fashioned abbreviation for etc. Okay? So if you ever see that in your writing, and C, it is the exact same meaning as etc. So you see that's at the beginning of paragraph 37. If A be taken twice, 3 times, etc. Okay? So for us, we actually have etc. already in the dictionary, and you can look it up one of 2 ways, either etc. Oh, I thought I put it in as etc. I guess not. Is it just etc? Yes. So that is etc. and it's et s for etc. You can also look it up according to the Latin, etc. Right? And both come up as the same value. All right, so that is etc. So if you ever see ampersand C, then it stands for etc. Etc. Comma. The results are represented in algebra. The results are, results. Is that written as, is that a backwards S? Nope, it curves on down, All right. The results are represented, and represent is R. Isn't it? It's RP. It's not RPR. It is represent. It's just RP. Can't get any easier than that. Are represented by in algebra. Are represented in algebra. So this is the algebra if it's just by itself. ALJ. Algebra. Yep. Are represented in algebra by 2A, 3A, 4A. Oh, let's do that down here. 4A, etc. The sum of any 2 of these series, the sum of any 2 of these series is it SERES or is it just SR? I think it's just SR. No, that's serious. Serious is, let's see, let's look at the difference between those. Series. Yes, series requires SERES, and serious is yes, it's SERS. Okay, so that's the difference between them. The sum of any 2 of this series may be expressed. Once again, we can do maybe as a really nice phrase. Maybe, and then expressed is EX. Is it EXPR, and then it would be a D underneath? Let's check and see. Expressed. So obviously we don't have the past tense, but this is close enough. So express, and if that's express, then we would need the disjointed T underneath as well. So there we go. So we'll do EXPR and then that value there for expressed. In a shorter form, there we go. May be expressed in a shorter form than by writing, the sign. Oh, make that S just a little smaller, otherwise it looks like an F. Maybe written by the sign, the plus, right? Or the plus sign between them. Semicolon. For though we do not know what number A stands for, though we do not know what number A stands for, comma, we know that comma, be it what it may, that's a lot, that's like a phrase just waiting to happen, isn't it? Be it what it may. It's like a legal phrase or something. Be it what it may. We could do what it by doing a slight jag. I know that you can do just a long one. I find I like to do a slight jag. What it, right? Be it what it may. Okay. Comma. 2a plus 2a. 2a plus 2a is equal, and let's go ahead and move this down one line. 2a plus 2a is equal to 4a, comma, and then 3a plus 2a is equal to 5a, comma, and then 4a plus 9a, and so on and so forth. If I can write, hold on. My mind is blanking out. Yeah, this is the correct way to write 4. 4a. 4 gets me for some reason when it's written backwards. 4a plus 9a plus 9a is equal to 13, is equal to 13a, semicolon. And generally, I think it's that one, right? No, let's see. No, it's an L, because general is just gen. So let's go take a look at generally. Oh, Jenny. Okay. I like that. If you know a Jenny in your life, then she's a generally. There you go. So there's generally, comma, if A taken m times. Oh, okay, so he's talking about constants. Look at that. In the second section of arithmetic, he's already talking about the difference between a variable and a constant. Crazy. So we can do if A taken m times, and generally, comma, if A taken m times be added to A, be added to A taken n times, comma, the result is, the resu is A taken m plus n times m plus n times, or mn m plus or m times a, ma plus n a is equal to m plus, oh, thank you, Mike. But et is and. Oh, that is clever. That is very clever, Mike. Thanks for sharing that. Wow. And the others. Oh, that is fun. That is fun. Thanks for doing that research. That is a lot of fun. All right, so we have MA plus NA is equal to M plus NA. And oh, look at that. He's already talking about the law of what is that? The communicative law, right? You know, you can, yeah, that's not associative, that's the communicative law, where you have the A and you can distribute the A across the expression inside. Wow, that's fun. Okay, so that's the end of 37. So now we'll go ahead and read back over it, and this would be the sort of thing that you'd want to have memorized, right? MA plus NA is equal to M plus N times A. So really important stuff. And now let's go back to the previous paragraph marker and hope. This one I did remember. Yes, hey, look at me. I'm smart. I'm learning. I remembered to put a marker here. It only took like a month of streaming before I got it. Okay, 37. If A be taken twice, 3 times, etc., and the result will represent. The results are represented in algebra by 2a, 3a, 4a, etc. The same of any two of this series may be expressed in a shorter form than by writing the sign, which is the plus. Was that supposed to be a parenthesis, by the way? No, the sign, the plus symbol, between them. Let's see, what is that? Between them. 4. Is that 4? Yeah, 4. Yeah, but that is a disgusting 4. Or let's go ahead and fix that. That F needs to curve down. There we go. That's more like it. For though we do not know what number A stands for, we know that be it what it may, and then I jumped a line, 2a plus 2a is equal to 4a, 3a plus 2a is equal to 5a, 4a plus 9a is equal to 13a. And generally, if a taken m times b added to a taken n times, the result is a taken m plus n times, or m plus a, or ma plus na is equal to m plus n, and then to all times a. All right. Very nice. Very nice. Okay. Now we continue on. Oh. Once again. There we go. All right. Moving on down. 38. Move down the page over here. Save the document. That is one thing. If anyone ever decides to use Zernal for their digital copywork, it can be very temperamental, so you want to be saving it a lot, because it will freeze and then you'll lose a lot of work. It doesn't have a very good autosave. But other than that, it's a great piece of software. I really enjoy it. It's there's a link down in the description if you want to take a look at it. It's open source, free, and available for all platforms. So PC, Linux, and Mac. So that's Zernal++ or Zernal PP. All right, so let's go take a look at 38. The use of the brackets must here be noticed. And by brackets, he means parentheses, what we would consider parentheses, okay? So 38, here's our 38, so let's drop another paragraph marker, go ahead and highlight it, and we now continue as 38. Okay? The use of the brackets must here be noticed. And we could do the use of the brackets must here be used, or must here be noticed. Must here be noticed. All right. Thank you so much, Mike. You have a wonderful day. It was a pleasure having you here. Hope you have a wonderful rest of your evening or day or wherever you are. Take care, my friend. Must here be must here be noticed. Noticed. N-O-T, and then should go up as well, right? So if we go noticed, we take a look at the dictionary. There's notice, and it does require the E stroke, okay? So let's go ahead and add that. And that would be noticed. All right, so let's go ahead and save this here. I'm going to go ahead and add another page below. So this is going to be the Elements of Arithmetic, section 2, and page number 7. There we go. All right, so we'll zoom over here. Go ahead, get started. Be noticed. So we're currently on paragraph 38. All right, period. They mean that the expression, they mean, comma, that the expression, I think, is expr shun, right? Let's go ahead and check it. It requires the E on the base. So we'll do expression. There we go. That the expression contained inside them, and contained is contained, like so. Check and see if that is correct. Go over to the dictionary. And it is, so then contained would simply add the T afterwards. They mean that the expression contained inside, and that's going to be in. Now here's a tricky one. It's inside. The S is turned backwards. So let's go ahead and check that. Inside. Take a look. Even better. It doesn't even require the D. So we just flip it around here. There's inside. Now I do want to check, is that because side? Oh, well in that case I made a mistake earlier because I had side with the S diphthong D. So just remember that side can be written as just the S diphthong. S diphthong, like that, okay? So here's inside. They mean that the expression contained inside them must be used, must be, and must be would actually make a really good phrase as well. Must be used in the same place. In the same place. Period. Thus, PA signifies that A is taken P times. Thus, I need to check thus. Does it have a U hook? Is the U hook after the TH or is it integrated? Thus. It is integrated into the T, into the TH stroke. So we're going to go ahead and curve that over and then down. So there's thus. Thus, comma, PA signifies that A is taken P times. Signifies. This is going to be sig. And is it sigize for signifies? Let's see here. Oh, it's even easier. It's just SG. Just SG. Okay. Signifies that, thus PA signifies that A is taken, that A is taken P times. P times. And M plus N by A and M plus N in parentheses times A, comma, that A is taken M plus N times. That A is taken M plus N times. Plus N times, period. It is, therefore, comma, a different thing from N plus NA. It is, therefore, a different thing from m less in A, comma, which means that A, comma, after being taken n times, after being taken in times, is added to m. Is added to m, period. Thus, and then he gives an actual real example. Thus, parenthesis, 3 plus 4 times 2 is 7 times 2, or 14, semicolon. Well, 3 plus 4 times 2 is 3 plus 8 is 3 plus 8, or 11. And that's the end of paragraph 38. So what he's saying there is that you have to be careful with what's called distribution, or the distributive law, where you can distribute a value over an expression, but you have to be careful that just because you see one value in one place does not mean that it's not going to mean the same thing. So you have to be very careful with your distribution and who exactly gets the multiplication. So let's go ahead and read through this, starting at 38. The use of the brackets must here be noticed. They mean that the expression contained inside them, so let's make that them just a little bit longer, more pronounced. Inside them, there we go, must be used in the same place. Thus, PA signifies that A is taken P times, and M plus N times A, that A is taken M plus N times. It is therefore a different thing from M plus N times A. See that? So no brackets. See that? There are no brackets here. So we have M plus N times A, which means that A, after being taken in times, is added to M. Thus, 3 plus 4 times 2, so in brackets, in parentheses, 3 plus 4 times 2, which is 7 times 2, or 14, while 3 plus 4 times 2 is 3 plus 8, or 11. So brackets are really quite important. All right, so there's that paragraph. And we continue. So we go on to 30. Oh, zooming in again. Don't be zooming in. There we go. So we're going to scroll down. We're going to take a look at 39. So this here is talking about the rules of subtraction. Okay, so let's go ahead and start in on 39. Grab our little paragraph marker here and highlight it, and we start. 39. 39. When one number is taken away from another, when one number is taken away from another, comma, the number which is called, which is left, which is left is called the difference or remainder. Remainder, isn't that the one where it's just I don't think I've ever had to do remainder before. Check that. It's called the remainder. Over here. Ah, okay. So it's just R-E-M, so it's like remember. Remainder, remain, and remember are the same, aren't they? Let me check, wow. Is that true? Is remember and remain the same? So here's remain, yep, and now let's check out remember. Yeah, look at that. Remember and remain are the exact same stroke, so context alone is going to have to tell you the difference there. But what that means is that remainder is simply going to be the stroke, and then we use the reversing R principle to get remainder. Okay, so try and make it at least three strokes long. All right, so there is remainder. Which is left is called the difference or remainder. Now notice those are italicized. So in order to show the italics, we do two long strokes underneath in order to differentiate from just a line or a separation. What's that, Seagriff? Yes, yeah, remainder has... good to see you, by the way. Yes, so remainder has the... yep, it has the backwards R. Good to see you. Hope you're doing well today. Always good to see you here. So here we have the left is called the difference or the remainder, period. The process of finding the difference is called subtraction. The process of finding the difference is, let's move this down here, is called subtraction. Subtraction. Okay, let's go ahead and make this just a little bit more pronounced. There we are. Is called subtraction. And like I said before, they do a funny thing. This also, so this idea of doing all caps, see that? The all caps, it's called, what's that called? Lower capitals? Or there's a special name for it. You can use it on LibreOffice, for instance, but it's like minuscule capitals or something like that. But anyway, it's a way of just showing a slight difference. Oh, you had an argument on X. Oh, over there. That is funny. That is funny. Hopefully you won. Hopefully you won over the distributive law. It is one of the most foundational, it's one of the most foundational rules there are. So anyway, those are called like minuscule capitals or something like that. So anyway, but for now we can do that. I've been kind of being cheeky, and I do a double or the lines underneath to show that it's capitalized, and so I do that and then that on top of it, and that's like an extra level of importance. Okay, you don't need to. I'm just I enjoy the lowercase capitals, so it's fun to kind of signify them. And then we move on. We have the number which is to be taken away. The number which is to be, which should be just a little longer, which is to be taken away. Oh, that is so funny. That is so funny, Sean. I tell you, I think people are getting more and more dumb as time goes on, that they just can't understand that process. But that's what, that's what the beauty of the internet is here for, is both to show ignorance, but also to stamp a little bit of ignorance out. So the number which it is to be taken away must be, of course, the lesser of the two. The number which it is to be taken away must be, of course, the lesser of the two. Must be, of course. Now this is an interesting phenomenon. So, and this was one of the points of concern that someone raised about De Morgan, about using De Morgan's work, is that, I mean, I haven't read the rest of the book. I'm kind of working through it as I go, but apparently he really doesn't get into the concept of negative numbers. I mean, of course, they were understood, but as far as a concept that was being taught, it wasn't quite as prominent or as prevalent in his work. So the idea of the number line, which of course is so foundational and universally known today, apparently, if I understand correctly, and maybe I'll be pleasantly surprised, but apparently he really doesn't deal with negativity too much. So, negative infinity going off to infinity. I'm sorry. I know I apologize. That's backwards for you. This is infinity for you. This is negative infinity over here. I think you're right. I think you are right, Sean. So there we go. So there we have the infinity and negative infinity over on that side. So, anyway, yeah, it was kind of interesting. But he is saying here, like, when he's talking about subtraction, right? The number which is to be taken away must, of course, be the lesser of the two. We know, of course, that that's not completely true, because you can have negative values, but I can understand how it could be confusing for someone. But I need to check lesser. Okay, yeah, so that is lesser. I just have to make sure that we have the double E. There we go. Lesser must, the number which is to be taken away must be, of course, the lesser of the two. The lesser of the two. Okay, there we go. All right, so that is paragraph number 39. So I'm going to go ahead and drop a paragraph marker here. And now, obviously, if I'm using the numbers, I wouldn't have to do a paragraph marker. I'm just doing it out of habit to train myself to constantly think in terms of the number, or of the paragraph markers. Okay, so there's number 40. So let's go read back over 39, where he's introducing the beginning of our concept of subtraction. When one number is taken away, And let's go ahead and make that dot just a little bigger, the aspirate. In that case, symbolizing away. Number is taken away from another. The number which is left is called the difference, or the remainder. The process of finding the difference is called subtraction. The number which is to be taken away must be, of course, the lesser of the two. Okay, so that's the part, like I was saying, that assertion, right? The number that must be taken away must, of course, be the lesser of the two. I mean, that's just not, it's not true. It's just, you just throw a negative in front. But anyway, that's an argument for another time. I'm not going to quibble with the right Dr. De Morgan here about such small things as negative numbers when he's already presented such amazing concepts at such an early stage. So anyway, I'll leave that for for lesser beings to besmirch the writings of Dr. Morgan, and maybe they can write a better textbook. All right, so here we go. Paragraph 40. The process of subtraction depends upon these two principles. The process of subtraction depends on these, oh, come on, there we go, on these two principles. These two principles. Okay. And period. Here's our first one, Roman numeral. So we'll go ahead and drop a paragraph marker. I'm not going to mark it with the green highlighter though, because it's more of a separator. I wouldn't really be too interested in jumping back up and reading through, and reading each one separate. The difference of two numbers is not altered by adding a number. The difference of two numbers is not altered. Now here's interesting, altered. Because I know you can use started, right? You can do start, right? STA, and if you do altered, could you, and Sean, this would be a question for you, or for anyone else, but you definitely, with altered, can you just continue the stroke up, or do you have to break it off? I'll wait a couple seconds. I'm going to treat it as though you can. As though you can continue the stroke up. I mean, it makes sense, right? That's alter. It would be altered, ud. And you could make sense of it using Gregg principles. But if we look up alter, yeah, it's not in the dictionary. I wouldn't expect it to be, but using the same analogy as start, because this is start, and started, it just continues all the way up. So if you hear that consideration, Sean, then maybe just drop a comment. If I'd like to know what your practice is. Is not altered by adding a number to the first, comma. Oh, okay. All right. Well, thank you so much. By adding a number is not altered by adding a number to the first. If you add the same number to the second, if you, you could do you connected to the if you, but I'll keep it separate. If you add the same number to the second, if you add the same number to the second. I need to check second. I'm pretty sure that is correct. And yep, that is it. Maybe the D doesn't have to go up quite as extremely. There we go. The second. Scroll down a little. If you add the same number to the second, semicolon, or by subtracting a number from the first, or by now, okay, so subtracting, yeah, it's just a dot added to the end. Subtracting a number from the first comma, if you subtract the same number from the second. If you subtract the same number from the second, period. Conceive 2 baskets with pebbles in them. Conceive. That is conceive, I believe. So isn't that the one that you go? Isn't that conceive? Let's go take a look. Nope, curves the other way. What is that one? I just used that one. Oh, it'll come back to me, but it's an interesting word. Oh no, I'm thinking of perceive, right? That's perceive, isn't it? Oh, of course I can't spell it. Let's see. EI. There we go. Yes, that's what I was confusing it with. So conceive and perceive are different forms altogether. So this one is, yeah, that one right there is perceive, and conceive does the backwards S, curving back in on itself, right? Yes. So there is conceive. All right. Conceive 2 baskets with pebbles in them comma, in the first of which are 100 pebbles more than the second. In the first of which are 100 more pebbles, or 100 pebbles more than the second. 100, the first of which are 100 pebbles more than in the second, period. If I put 50 more, if I put 50 more pebbles into each of them, into each, oh, come on, there we go, each of them, comma, there are still only 100 more. There are still only 100 more in the first than in the second, than in the second, comma, and the same if I take 50 from each. Period. Therefore, in finding the difference, therefore, in finding the difference of two numbers, comma, if it should be convenient, if it should be, oh, and should be is a good one. If it should be convenient, convenient is a I don't think it even needs the E, right? Isn't it just KVNT? Let's check. Oh, okay. Now, boy, it's even shorter. No need for the NT, it's just convene. There we go. Therefore, in finding the difference of two numbers, if it should be convenient, comma, I may add any number I please. I may add any number I please to both of them. To both. Is that both? Let's see both. Very nice. Any number to both of them, comma, because though I alter the numbers, oh, hold on. I'm having a brain moment here. Because is it just a U? Yeah, it's just a U. It's not really. Yeah, it's like an O hook turned on its side. There we go. Because though I alter the numbers themselves, though I alter the numbers themselves, by doing so, by so doing, comma, I do not alter their difference. I do not alter their difference. Period. And then since, hold on, how long is this one? 6, 3, 4, 1. Okay, so yeah, we can do number 2, and then we'll be able to go back and reread through. So their difference, and then a paragraph marker here. And then we have number 2, Roman numeral number 2. Since 6 exceeds 4 by 2, 6 exceeds, that's going to be E-X-E-D, right? Exceeds. And that's right, exceeds. Good old exceeds. Those are germination vessels that no longer want to do their job. Exceeds. I'll see myself out. Since 6 exceeds 4, by 2, comma, and we're just going to continue these down, and 3 exceeds 2 by 1, comma, and 12 exceeds 5. Oh, 5 goes the other way. 5 by 7, comma, new paragraph, 6, 3, and 12 together exceed 4, 2, and 5 together. 4, 2, and 5 together, or 11, or, 11, comma, by 2, comma, sorry, didn't mean to bump into the microphone, I apologize. 11 by 2, 1, and 7 together, or 11 by 2, 1, and 7 together, by 2, comma, 1, and 7 together, comma, or 10. All right. The same thing may be said of any other numbers, and then we get to go back and reread through this. The same may be said of any other numbers. Of any other numbers. There we go. Drop a period, and then we go back and reread through. Let me go ahead and mark this, though, as another paragraph, and this is going to be paragraph number, this one is 41. All right, so there's 41, paragraph 41. Grab our little highlighter, drop that there. All right, and now we jump back up and take a look at our previous paragraph and reread through. So there we are, number 40. Here we go. Save the page, and we start. 40. The process of subtraction depends on these two principles. The first is the difference of two numbers is not altered by adding a number to the first. If you add the same number to the second, okay? Or by subtracting a number from the first if you subtract the same number from the second. Period. Conceive two baskets with pebbles in them. In the first, forgot the S for first. Oh, there we go. Clean that mess up. There we go. In the first period, or not period, I don't think it's even a comma, right? Take a look at it. Yep, there's in the first, okay? In the first, move on over here. of which are 100 pebbles more than in the second. If I put 50 more pebbles into each of them, there are still only 100 more in the first than in the second. To make that then just a little bit smaller, need to show some better consideration for the difference between a them and a then. It's caught me a couple times. So there we go. All right. Here we go. Then in the second. And the same if I take 50 from each. Therefore, in finding the difference of two numbers, if it should be if it should be convenient, I may add any number I please to both. Once again, that's another very important algebraic concept. I may add another to both because though I, and let's change that, though, needs to swoop up a little bit. There we go. Though I alter the numbers themselves, by so doing, I do not alter the difference. So you see the difference is the important part. And here's the second point. Since 6 exceeds 4 by 2 and 3 exceeds 2 by 1 and 12 exceeds 5 by 7, 6, 3, and 12 together exceed 4, 2, and 5 together, or 11 by 2, 1 by 1 and 7 together, or 6 or 10. So you see that there, that he's talking about how if it's ever convenient, you can add numbers, and therefore you can add the names for numbers, right? You don't have to add explicit numbers. You would add the names for numbers in certain contexts where it's going to be advantageous for you, okay? All right, moving on. And here's where he explains it, and then he gives that rule. So you remember we had a rule very similar to this with addition, and it was the idea of the distributive law. And now he's doing the same. The brackets here cannot be removed, as in 36. So you see here, these are important, the differences. All right. So let's go ahead and lay this out. This is paragraph number 41. Okay, let's go ahead and add a page below this. Page number 8, so this is Elements of not Elements of Animation, that's Alan Becker. Or let's go ahead and do, let's add Elements of Arithmetic. Elements of Arithmetic, section 2, and this is page number 8. Very nice, very nice. Oi, almost done. I got 25 minutes left, and then I can go get my dinner. Dinner sounds like a great idea. All right, so jump back up here. What I can do is I can get a drink of water. Water is always welcome. Okay. So 41, if A, B, and C be three numbers, here we go, if A, B, and C be three numbers, comma, of which A is greater than B, of which A is greater than B, according to paragraph 40. I, 40, number I, or letter I, section I, this leads to the following, okay? Leads to the following, comma. And we're going to go ahead and move this down to the, or move it to the other line. Here we go. Open brackets. And that one is A plus C, A plus C, minus B plus C is equal to A minus B. Let's move this whole operation down one level. There we go. All right. Which then means, again, if C be less than A and B, again, if C be less, is it LES or LS? I always forget that one. It's LES, yeah, it requires the E vowel. If B be less than A and B, comma, again, if C be less than A and B, then we get this expression, or this equation here, which is A minus C minus, and then in our next parenthesis, it's going to be B minus C is equal to A minus A minus B. Okay, there we go. I lead the following. So we have here that A plus C minus B plus C is equal to A minus B, right? Because you can add the same to both, and it's not going to change the difference. And that's really powerful. You see that? See that? So the sum, provided that A is greater than B in this instance, right? Provided that A is greater than B, if you add the same quantity to both values, if you're still finding the difference, it is still going to be equal to the difference. The sum added to both, it's going to cancel itself out, right? As you see here, same thing. I can remove the value of C from both A and B, and it's not going to change the difference. All right? The brackets cannot be here removed as in 36. So that's our follow-up. The brackets cannot be here removed as in 36. The brackets cannot be here removed, and remove, I think it's just remove, right? Remove. There we go. Cannot be here removed as in paragraph 36. That is P minus Q, and Q would go this way now. Q minus R is not the same, is not the same thing as P minus Q minus R, as P minus Q minus R, period. For in the first comma, the difference of Q and R is subtracted from P. The difference of Q and R is subtracted from P. Semicolon. But in the second, first Q and then R. But in the second, first Q, then R are subtracted from P. R subtracted from P, which is the same as subtracting as much as Q and R, which is the same as subtracting as much as as Q and R together. As much as, oh, and this is the case we're going to do as much as, right? As much as, and it curves back around. As much as Q and R together. Q and R together. Tog. Gotta check together, isn't it? Is it tog, right? No, it is tug. Tug. It's tuga. Oh, sorry. Bumped against the mic again. All right. Last 15 minutes, folks, in here for the final stretch. Oh, this is fun. All right. Together. Or Q plus R. Or q plus r, q plus r. Therefore, p plus q, or minus, sorry, not yet, p minus q minus r is p minus the sum. Let's do it. I think I'd have room right here if I do p minus the sum of q and r. All right. In order to show how to remove the brackets and remove the brackets from p minus, hold on, no, it's q, bother, from p minus, and then in parentheses, q minus r, without altering the value of the result, without altering the value of the result, let us take the simple instance. Let us take the simple instance. Oh, that's interesting. I haven't used instance in a while. There's instance. ENS. Hey, you can't beat that. Can't beat that at all. Love it. Let us take the simple instance of 12 minus 8 minus 5. 12 minus, and then in parentheses, 8 minus 5. Okay? Period. If we subtract 8, if we subtract 8 from 12, or form 8 minus, or form 12 minus 8, or form 12 minus 8, comma, we subtract too much. We subtract too much, semicolon, because it is not 8 which is to be taken away. Because it is not 8 which is to be taken away, because it is not 8. It is not 8 which is to be taken away. Comma. But as much of 8 as is left after diminishing it by 5. But as much of 8, as much of 8 as is left after diminishing it by 5. Diminishing. What is diminish? dm isn't it this one where we have to go dm in ish, right? I think it's that. And then diminishing. Let's check. Yep. And diminishing. Whoop, there we go. Up we go. Diminishing it by 5. Okay. Period. Informing 12 minus 8. Informing 12 minus 8. We have therefore subtracted 5 too much. We have subtracted 5 too much. Period. This must be set right by adding 5 to the result. This must be, so there we go, there's another must be set right by adding 5 to the result, a comma, which gives 12 minus 8 plus 5, which gives 12 minus 8 plus 5. Very nice example. I really like what he did there. For the value of 12 minus 8 minus 5, of 12 minus, in parentheses, 8 minus 5. There we go. Period. The same reasoning applies to every case. The same, oh, what is reason? Is it reasoning, right? Let's check that. Yep, that's it. The same reasoning applies in every case, and apply is going to be P, is it? I think that's it. And then applies would simply drop it down there. Yep, that's apply. The same reasoning applies to every case, comma, and we have therefore, an identity, which is P minus Q plus R being equal to P minus Q minus R. And then the next one below that would be P P minus Q minus R being equal to P minus Q plus R. Okay, so those would be two examples of the identities. Okay? All right. Oy, okay, and is that the end of the paragraph? By the same reasoning, by the same reasoning. By the same reasoning. Okay, by the same kind of reasoning. Kind of reasoning, comma. Move over there. Oh my goodness. Okay. Wow. All right. Yeah, let's write them out. We've got about 3 minutes left. Let's just go crazy over these last three, and then I can take a break and then come back and reread paragraph 41. Okay, so we have A minus B plus C minus D minus E minus E, close parenthesis, would be equal to A minus B minus C plus D plus E. Okay? The one below it then would be 2A plus 3B minus A minus 2B is equal, would be equal to 2A plus 3B minus A plus 2B. Yep. Plus 2B. Okay. Which then would be equal to, man, can I truncate this at all? Let's maybe make it a little smaller. Just shrink it down just a hair. And then we should have enough room to then add the simplification right here, which is then equal to A plus 5B, which is equal to A plus 5B. Okay, nice. Good. Oh, 1 minute. 1 minute and 41 seconds left. Oh, man. Oh, all right. So 4x plus A. Here we go. 4x plus y plus y. All right. Y minus, and then in parentheses, we have 17x. 17x minus 9y, close parenthesis, is equal to 4x plus y minus 17x plus 9y, which is equal, the final one is equal to 10y, oh, backwards, 10y minus 13x. I'm running out of room. 13x. There we go. All right, and with that, 30 seconds left. I'm done. I'm gonna go get some. I'm gonna go get some dinner. I'm gonna take a little break, and I will be back. Let's shrink you up a little bit. There you go. All right. Save the document. Oh boy, that was crazy. All right. Well, thank you very much for joining in. This was a really good session. What did we do? Did I get 10 paragraphs copied? I can't remember. But anyway, great practice overall. Thank you very much for joining in, and wish you all a wonderful evening. It's currently almost 5:30 here. It's 5:27, so that was a good session, and I will see you shortly for the final set for tonight. Probably only get it about 2 hours done because I have an early morning tomorrow, and yeah, so we'll call it there. I'll be back at around 6:30 probably, maybe 6:15, 6:30. So thank you so much, and take care. Bye-bye.